Hello everyone, I think we can start this webinar. So good morning to all the attendees, and first of all let me thank you for your assistance to this webinar, and in which we will highlight our alliance with NodeWeaver. So my name is Abdel and I am a system engineer at Virtual Cable, the manufacturer of UDS Enterprise. So also Carlo D'Afara, CTO of NodeWeaver, is present with us today, and he will make a presentation and a technical demonstration of NodeWeaver and show us how it directly integrates UDS Enterprise through their marketplace. Carlo will also show us how to request and access NodeWeaver trial version. After his technical demonstration, I will show you how UDS Enterprise connects with NodeWeaver and how it deploys virtual desktops on NodeWeaver in a very simple way. So before we start, let's introduce UDS Enterprise and NodeWeaver Alliance. So UDS Enterprise is a VDI connection broker that serves for Linux, Windows, and virtualization of applications as well. And about NodeWeaver, it's a zero management hyperconverged infrastructure that integrates storage, networking, and virtualization in a single system based on the famous Open Nebula. So why UDS Enterprise and NodeWeaver? In fact, the alliance and the integration of UDS Enterprise and NodeWeaver allows us to enjoy an open source turnkey solution running on hyperconverged platforms, which integrates distributed storage, SDN, and private cloud functionalities. It also allows us to easily deploy and manage high-performance virtual desktop infrastructure and applications with multiple hypervisors, multiple authenticators, and multiple connection protocols simultaneously running in the same platform with no limitation, and also allows and enables a strong, secure, and efficient VDI infrastructure with distributed storage. As a result of this alliance between UDS Enterprise and NodeWeaver, all the customers of this latter will receive a UDS Enterprise subscription of 10 users for free. And in the end of this presentation and webinar, we will be glad to answer all your questions concerning our joint solution. So I will let Carlo D'Afara, CTO of NodeWeaver, give his presentation of NodeWeaver and show us how it does integrate UDS Enterprise virtual appliances directly from their marketplace. So Carlo, please go ahead with your presentation.
Thank you and welcome. My name is Carlo D'Afara and I am CTO of NodeWeaver. NodeWeaver is a hyperconvergent and private cloud system designed to bring the flexibility of the public cloud to any company with the same reliability and the same pay-as-you-go model. We know very well the issues that SMEs and public administrators face. They would like to have the kind of flexibility and reliability of large-scale cloud provider while having to work with limited resources. Every time you have to do substantial change, like updating your virtual servers or change a complex configuration, you have to hope that everything works afterwards. You have to face any kind of disasters, either caused by water, fire, or human errors. And we know that SMEs have to manage too much. Most of the IT solutions that are offered are complex, difficult to manage, and many times the end user has to put together pieces from many different vendors and hope for the best. That means that most of the time and effort is not spent in productive ways. It's just a sunk cost, work done to keep the lights on. 3/4 of all work in IT is done exactly to do so, just keeping the lights on. We were born from a European research project designed to help SMEs and public administrations in taking advantage of new IT systems. We created NodeWeaver to be a simple solution to a complex problem. We run any kind of workload, be it virtual servers or desktop, on any hardware and remote service like a hosting or colocation or public cloud. Installation is very fast and simple, and the new cloud can be started in less than 5 minutes and requires just an IP address to reach the web console to start. It's capable of handling all faults on its own. Disk, network, entire nodes can go down and require no user intervention, and it's priced to be competitive and usable by SMEs of all sizes and can be licensed monthly or with a lifetime license. In a sense, we run everything. We're leaving you in full control from anywhere with a web browser, and we survive any kind of fault. And this system is scalable. You can start with just 2 nodes and grow to any measure you need. Our secret is in how we handle data. Anything is split into small data chunks and moved to where it is used, as if it was water. Each chunk knows where it is needed, where a replica is needed, if it is required to be on a fast storage or not. All of this without the needs for user intervention. The user interface can also adapt itself. It can be simple or powerful. You decide. We know that there are many hyperconvergence solutions in the market, but we are different because we run on hardware you have now of any maker. We have a flexible licensing to help you grow without making you pay in advance. We are simple. We are open to help you adapt NodeWeaver and provide your services on top. And we can run where other platforms can go. And this is a very interesting market, one that grows leaps and bounds, especially because the majority of servers are in small rooms and server closets where our flexibility and maintenance-free operation shines. We know that we have lots of competitors, but most of them are so costly that no SMEs can afford them. We can, because we can take advantage of European research investments and many past and ongoing projects that are financed by the European Union that created the components that we use in our platform. And our offering does not cover only the software. We provide a full set of services designed to help you and your company to take advantage of our platform in an optimal way, include remote monitoring and auditing. We can support you anywhere in the world thanks to our partners in North America, Europe, Russia, and now Australia as well. We know what SMEs need because we worked for them for many years and we have listened to what they need. We have helped them and we worked with them for more than 20 years. This helped us reach more than 200 installations in all sectors, including multinationals and very large public administrations. And our customers love us, and the analysts love us as well. And this helped us in reaching many international recognition. And now we hope to be able to win your trust as well. And to do so, I will try to give you a glimpse of how NodeWeaver works. We will now give you an overview of the NodeWeaver web management interface that is used to control all aspects of your private cloud. The first thing that we see in the default configuration is the cloud dashboard. This page is designed to give you an at-a-glance view of all the resources in your cluster. The system is controlled from the menu on the left that we will explore, starting from infrastructure, that gives us a view of the physical components that underlie a NodeWeaver cluster. The first item we'll see is the distributed storage tab. It gives you an overview of how data is managed on which disks and how the storage underlie is performing. The first tab, the Info tab, gives you an overview of the individual data blocks that are the basis of our distributed file system. Every object, be it the cloud platform data itself or the virtual disks on your virtual machine, is split into blocks of variable size called chunks. Chunks contain data, but not only. They also contain additional metadata like a CRC that helps us in identifying corruption, or what we call the goal, that is how and when a block needs to be copied or placed somewhere. We can see, for example, that the majority of the chunks in our platform are in goal 2, and some in goal 3, some in goal 4, and some are marked for deletion, which means that the sweeper process will delete them from the system since they are not used anymore. Chunks may have different placement strategies. We may ask to have just 2 copies and the system will try to place them in the best place in terms of latency and space allocation. We can ask for explicit having 2 copies on SSD or having 2 copies on HDD or any combination. There are several additional goals including erasure coding, multiple copies, up to 10 copies of every chunk that are used and can be applied to any image that is being executed inside of our platform. It is also possible to change goals live while the VM is running without any form of disruption. NodeWeaver handles all the disks directly. This way, it's possible for us to identify immediately if some physical device is experiencing problems, or for example, it is slowing down, giving us the opportunity to balance in the optimal way chunk allocation to make sure that your virtual machines always run at the fastest possible speed. NodeWeaver handles all the disks directly. This way it's possible for us to measure the low-level properties of the physical devices and, for example, identify disks that are starting to express problems in their low-level write or read properties, or slow down, or are defective. The system handles any kind of defect on its own, and it's able to dynamically reallocate reads and writes and replicate data to make sure that the speed properties are maintained and the reliability of the system on its own is constant. Everything is managed through a set of long-term data probes that collect information from all the disks in the cluster and perform a predictive capability to make sure that we are able to identify systems that are starting to fail or systems that are not performing as they have to. We are able to dynamically reallocate reads and writes to make sure that the system continues to work and is capable of providing the required performance even if something drastic happens. For example, if a node disappears or a new node appears and all the replication needs to be performed anew. This way, you don't have to worry about anything, and you know that the system is capable of managing on its own and will just warn you with an email. The next point we will look at are hosts. The host management interface automatically adds a new node that appear on the cluster or manage nodes that do present problems to make sure that the system as a whole continues to work as expected. Every system provides its own diagnostic system that are based on a set of small executable programs called probes that are sent to each node and they are continuously executed to monitor what happens inside of the system. It's able to extract information directly from the low-level hardware components or from EPMI or from any other sources to warn the user if something happens or to perform actions like, for example, shutting down a system that is not behaving in a proper way. Hosts are managed directly through the web interface, and it is possible to see the real CPU and memory consumption of the system and to check which VMs are being executed on top. It's even possible to disable the node or put it offline to prepare the system. The next area we'll explore is the network section. Virtual networks are managed by an internal software-defined networking layer which is hidden inside of the NodeWeaver hypervisor, and it is enabled by a distributed virtual switch that encompasses all the nodes inside of a cluster. Virtual networks are extremely flexible and can be created with a combination of Open vSwitch, which is able to manage VLANs, transparent bridges, or VXLANs. In any combination, it is possible to automatically assign addresses, be there IPv4 or IPv6 or any combination or pure Ethernet MAC address. And it's also possible to manage any kind of security groups, which are like small firewalls that are enabled directly on the virtual cable that connects a VM to the virtual network itself. It's also possible to assign quality of service capabilities to each virtual network. So it's possible to specify average bandwidth, inbound or outbound, peak or peak burst, independently one virtual network to the other. It's also possible to create any combination of virtual network and attach them to any virtual machine live. Network topology can be very complex, and it is possible to explore each individual network capability and network attachment directly from the network topology view, and it's possible to define additional security groups. So it's possible to, for example, assign inbound or outbound rules to any specified protocols for one or more port ranges and assign it to a specific network. This approach is extremely flexible and allows us to add additional security mechanisms for VMs that, for example, cannot be modified or cannot be extended to support an integrated firewall. The next section is storage. Within storage, we can create new images and assign them a goal. So, for example, we can have simple 2 replica, 3 replica, or decide whether they should be assigned to an SSD. Or it's possible to specify the kind of target device that needs to be emulated. It's possible to import images and even to convert images from existing virtualization platforms like VMware or Citrix. It's also possible to assign labels, so it's fairly easy to search just a subset of the images that you want to apply. NodeWeaver integrates a spatial marketplace of images that are directly managed by us. You can just, with a single click, like for example for the UDS server components, you just have to click here and those VMs will be automatically downloaded and created in your NodeWeaver cluster. This marketplace now contains some of the images we use every day and will be extended for additional virtual appliances like the one from our friends from UDS. The next part of the interface is templates. Templates should be considered sort of blueprints on how to create VMs. A template contains all the description and objects that need to be present for the VM to be instantiated. So, for example, we need to know how much memory should be allocated, how many CPUs and virtual CPUs should be defined for them, if you want to add one or more disks, and for each of these disks it's possible to specify additional parameters, like for example if you want to override the target device or if you want to specify quality of service variables like throttling in terms of how much the disk should be used in terms of total read plus write in bytes per second, only for reads, only for writes, and in total IOPS. This allows us to create VMs that can be perfectly controlled. It's possible to add additional disks when the VM is live. We can easily attach additional virtual networks up to 64, and it's possible to specify the kind of virtual machine that should be emulated or if you want to change the boot order. It's also possible to specify additional hardware emulation capabilities like the emulation of ACPI, if we need to have a limited form of Hyper-V emulation, or if the system should reschedule dynamically the VM to make them live migrate on the most suitable node in a continuous way. We support a dynamic screen which is created directly by the hypervisor, which can be connected through VNC or through a spatial protocol called SPICE that allows a full multimedia and USB remoting. It's also possible to decide how this VM needs to be scheduled, on which host we want to have them to be made available, or what kind of policy should be decided as to when to place the VM or when to move this VM if something happens to the nodes or the global load scheduling. The system that we use is peculiar. It's called p-value scheduling. Basically, every node does contain an engine that simulates what will be the performance of the VM if the VM is allocated to a specific node. This is a number that goes from 0 to 100, where 0 indicates that basically the VM would run at the maximum speed possible. The system then tries to allocate all the VMs so that each VM is running as fast as possible. This, of course, is dynamic. It changes every time a new VM is scheduled or when a VM starts to use more resources. For example, a mail server starts to use more memory or more CPU. It's also possible to assign custom PCI devices or to pass specific values down to the VM. Templates can be connected together into what we call flows. It's possible, for example, to say that we want a first VM to start and then a second VM to start as soon as the first one is booting, or it's possible to create dynamically cascades of VM activation or auto-scaling. So, for example, we can increase the number of VMs if something happens. Like, for example, if we want a web server to start responding to an increase in traffic, so we create more copies of it. It's possible to assign individual networks or to create a network on the fly. A special kind of services are virtual routers that are automatically deployed when you create connected networks across different VMs. Virtual routers are generated by the system, and there are small custom VMs that directly route from one network to the other in an automated way. From templates, we can decide to instantiate VMs. You can create as many VMs as you want from a template, and the individual VMs are then managed directly through this system. It's possible to see what the VM is doing in terms of capacity, to see how much the CPU and memory is being used by the system, to see how much read and write activities performed on the virtual disk. You can attach new disks or detach existing disks, and the same thing applies to networks. You can add more network cards or remove existing ones. It's possible to see what happened to the VM in the past, and it's possible to schedule actions. So, for example, we want to reboot this at a specific time in the future. It's also possible to investigate the logs and to see what happens. VMs can be suspended, stopped, restarted. It's possible to perform actions like a reboot or live migration and reschedule of the system. And of course, it's possible to connect to an existing VM through the web interface. It's possible to change the owner or group of this VM. So it's possible, for example, to make sure that the VM is handled by a specific user or group of users, and it's possible to add labels so it's easier to find this. The final part of our exploration of the NodeWeaver interface goes into the System menu. Here we can manage users and, for example, create new users or change the quotas and decide how many VMs or how much CPU and memory they can use. It's possible to see the activity that has been performed, and it's possible to calculate the showback for estimating the real cost of something that has been used by the user. So, for example, for companies that want to use NodeWeaver to do hosting or VM management, it's possible to assign specific costs to group of users. Groups are very flexible, and the system includes a very sophisticated access control list system that allows us to create rules or group the rules to decide who can manage each of the resources that are available inside of NodeWeaver. It's possible to assign rules by user, by group, or by cluster, and it's possible to decide what kind of operation can be assigned to each user. The last part is the service section, which includes the overall indication of whether the cluster is performing correctly and a set of diagnostics information to understand if everything is okay with the hardware. And it's also possible to create jobs that get scheduled, for example, to perform snapshots or to perform backups. And it's possible to import and export images from existing snapshots, and it's possible to re-import them or to explore any specific image. It's possible to import images from other platforms, and it's possible to import VMs from other platforms. This gives us a very good set of features to facilitate the movement from external or other virtualization platform and move them to our infrastructure.
So hello again, everyone, and thank you so much, Carlo, for your presentation and your valuable explanation of NodeWeaver. And getting back to our topic of how UDS Enterprise is deployed through NodeWeaver Marketplace. So as you can see, if you go to NodeWeaver platform, NodeWeaver dashboard, you can go to storage, and by clicking on apps, you can see these virtual appliances among others. So by just downloading UDS server and UDS tunneler, you can start deploying and configuring UDS Enterprise easily. And when it concerns UDS Enterprise edition, the full edition, you will need MySQL database. But otherwise, for UDS Enterprise free edition, for example, you just need UDS server and UDS tunneler, since the database comes embedded in the server. So after downloading, deploying, and instantiating these virtual appliances, you can directly start to configure your services in UDS Enterprise. So I've just logged in using my credentials. Let's go to dashboard to see how it looks like. So I will give you a quick tour of UDS Enterprise, in which we will see how NodeWeaver is integrated as a service provider, and also how a service is deployed, and we can also go back to VMs and see how VMs are deployed on NodeWeaver by UDS Enterprise. So this is the dashboard, and you can see the authenticators, services, used services, and restraint pools. Here you can see an overview of the system and all the components that are deployed and configured in this platform. So if we go to services, for instance, if we click on you will see all the service providers supported by UDS Enterprise. For instance, all these service providers can be configured simultaneously in the same platform. There is no limitation. And in our topic, we want to create a service based on NodeWeaver, which is based on OpenNebula. So we'll choose OpenNebula platform provider. We have already created a service pre-configured before, so we can save some time. By editing, we can see the fields that should be filled in a service provider of type NodeWeaver based on OpenNebula. So we just choose a name. The command is not mandatory, and we introduce here the host FQDN or the IP address of the host, the port, and username and password with administration rights. So by saving, our service has been created. Before we exit this section, let's check the service and scroll down to services and create a base service. So the base service in this case is called OpenNebula Live Image. So let's check some of the previously created services. For instance, this is a Ubuntu service. We just choose a name for the service and choose the data store where to save the services that are going to be deployed from this template. Here we choose the base template. When we click on the scrolling list, we can see all the templates available on our platform. So for instance, for the service is a Ubuntu service, we choose this Ubuntu 16.04. But UDS Enterprise has no limitations of OS, so it can support any OS flavor, be it Linux or Windows, and also virtual applications through RDS. And in the coming version of UDS Enterprise that's going to be launched in a few weeks, UDS Enterprise 2.2, we will also be supporting virtual Linux applications. That means applications over Linux machines. So here is the machine name suffix. All the machine names should start with this suffix, and the name length is 5. That means it's adding a concatenation of 5 characters made of digits to give a sequential number to the instances. By saving, our base service has been created. So again, in authenticators, a quick look. So these are all the authenticators supported by UDS Enterprise. And actually, again, the flexibility allows to deploy any of these authenticators simultaneously in the same platform at the same time. For our testing purposes, we have created an internal database in which we have created groups and users and assigned users to groups. So we made our special and proper policies. So in order to create an internal database, it's very easy. So you just choose, you pick a name for the database and the priority. The lower the digit is, or the lower the number is, the higher is the priority. And here it's mandatory to give a label. So by saving, our authenticator is created. Again, we check the authenticator and scroll down and we create groups. So by creating a new group, you fill in these fields and you choose the state enabled if you want it to be enabled. And then we create a user, you give it a name and the username, and if you want the user to be a staff member or even to be an administrator, and here you give a password of the user and you choose the group to which attach this user. By saving, our users have been created. So again, in OS managers, we have all these types of OS managers that can be deployed simultaneously in the same platform. For our case, for instance, we have created a Linux OS manager and a Windows OS manager, since we can deploy either Linux or Windows and also RDS applications, but for this case we didn't choose to show an example of RDS applications. So in an OS manager, for instance, we can choose any of these. You choose a name and a comment and what action to perform on logout. If you keep service assigned, means that you want to keep your services assigned, means you want to deploy persistent machines that even after logout or reboot of the machine, the personal space should be persistent. But if you want to remove service, then after logout, the session is deleted, and after a new login, there will be a new session loaded. And this maximum idle time is the idle time in seconds, that after this idle time of inactivity, the session will be closed. But if it's a persistent machine, this doesn't count. In connectivity, we can see all these protocols either in tunneled way or direct way. For tunneled, it's concerning access from internet or from the wide area network, or any access that concerns HTML5, since it goes through HTTPS or SSL tunnel. And when it comes to direct protocols, these are the protocols that can be accessed locally from inside the corporate network. So again, all these protocols can be assigned simultaneously in the same platform. So for calendars, calendars serve for task scheduling and access management. For instance, you can create an access management calendar that prohibits access after or between certain times, and you can also create calendars that schedule some actions or some tasks, for instance, to deploy services at a certain time, or flash the cache or whatever. And coming back to this last step of creation of UDS Enterprise services, it's service pools. So service pools is where we gather all the components together to give a recipe and create an OS flavor. So this service flavor is made of a name of a service, and we give a comment, and here we choose a base service. Is it a Linux or Windows or whatever? For our platform, we have created previously 4 services just for testing purposes, and here we choose the OS manager we want to use for this OS. For the display, we can upload icons or images to assign to our services, and also the pod groups, we can create folders or containers to contain groups just for display purposes. So for instance, in availability, in initial available services, the value shouldn't be null. And for instance, in this case, 1 should be more or equal to maximum number of services to provide. And in this case, we'll have 1 initially available service. In services to keep in cache level 1, we have specified, for instance, 1. That means that 1 service should be in a ready state, waiting for escalation to initial available services and get an IP and then be operational. Once a service is taken from cache level 1, we can also specify that we want some services to be in suspended state, that whenever a service is taken from cache level 1 to initial available services, this one is taken to ready state. So let's have a look at our publication of Windows 7. And in availability, for instance, we had chosen 2. Let's give it 5 and move on to NodeWeaver dashboard to see how services are being created. So here you can see that there is a service being created every 3 seconds, and the speed of creation depends on the performance of your system. So in order to be able to visualize our services or assign them to users and assign transport protocols to our services, we should check the service and scroll down to groups. And here in new, we can assign our group to our services. So all the users of the group UDS local group can access this service. And here let's add the transport to our service. Let's add RDP, for instance. By adding RDP tunnel to our service and go into user mode, and we can see that the service is now visible and available to all users in the group that has been assigned to this service. Before I close this presentation, let me just show you the last section, which is tools, in which we can find gallery. Here in gallery, we can upload images or icons to be assigned to our services. We can also find service pool groups. We can create folders to contain our services. And here you can see all the reports and generate reports of use and statistics, and everything can be found here, everything that has been generated by the system. And here you can see and you can manage the default values of all these parameters or all these components of your platform UDS Enterprise, and you can also see your security key that you will use to associate any actor or any template to your platform. And one important thing is flash the cache that serves to online update of your inventory. For instance, if you have made an update in your inventory and you want it to be visible in your platform, you just flash the cache and there is a new cache generated with the new data. So because UDS Enterprise has a security policy of blocking any user trying to attempt to access the server after a certain number of unsuccessful attempts to introduce the password, then by flashing the cache, you can authorize this user to be able again to access the server. So thank you for your attention, and I have done the tour of UDS Enterprise. And I am now ready with my colleague Carlo to answer any of your questions, and thank you so much.